Here is question number 5. All my questions are actually from the previous test papers, and I haven't even changed the names of the wording so that they become familiar to you. Somehow I've seen the teachers just repeating year after year the same questions, and so I thought, why not share them exactly as they appear in the test paper? So here is one. It says, Manpreet throws a ball out of a window of a building towards Shivani, who is standing on the ground below. The path of the ball is given by the equation h of t equals to minus 5t square plus 20t plus 15, where h is the height of the ball above the ground in meters and t is time in seconds after the ball is released. It's got A, B, C, D, E parts to it. It says how far above the ground is the window, when will the ball land at Shivani's feet, how high the ball reaches, when does the ball reaches the height of 10 meters, state the domain and range of the ball flight. Now that's actually a very good question, always seen in the test paper with different names. So it's a good idea to go through it. So I'll not give you a solution for this since there are similar examples in the book. But I'll tell you how to do it, right? Now here it is. How far above the ground is the window? Just plug in t is 0 because that is the time when the ball was thrown. So you know the answer is 15. You see? So you can write 15, but what you missed most of the time is the units. So I'm emphasizing on units, the things which you could miss and lose 0.5 marks for that. So it is 15 meters. And how do you get it? You get it by putting h of t for 0. So h of 0, when you calculate, you get 15. That's what it is. So when will the ball land at Shivani's feet? So at that time, ht is 0. So at this time, the height, ht equals to 0. So that means you're trying to find roots of this equation, right? To find roots of this equation, this is a very simple form of the equation. Sometimes it could be difficult, right? So I'll suggest if it is simple as that, you can always factor it and get your answer. So I'll suggest partial factoring as your technique of answering this question, right? So let me write this function in partial factored form, which is I'll factor these two terms, right? So it is minus 5t is common. So we get t minus 20 divided by 5 is 4 plus 15, right? So that is what you get. Now the zeros are actually at t equals to 0 and t equals to 4, right? And the midpoint gives you excess of symmetry. Why am I giving you this? Because I'll give you some more ideas about the function. This is called partial factored form. So this is our partial. We didn't really factor the whole thing, right? It is partial factor. So you from here you get excess of symmetry. That means you have a maximum at t equals to average of these two values. At t equals to 4 plus 0 divided by 2, which is 2. So at t equals to 2, you have maximum in this particular case, right? So how high the ball reaches will be when you plug in 2 here in the equation and get the value. So when you plug in 2 here, what do you get? That is how high the ball reaches, h of 2. Do you see that? H of 2 will give you the answer. So just plug in 2 in your equation and calculate the answer. That is how you are going to do it, right? Part D is when does the ball reaches the height of 10 meters? So in this case, when does the ball reaches the height of 10 meters? That means h of t is given to you as 10, right? So write h of t equals to 10. Use quadratic formula and find your answer. Do you see that? So you can write 10 here. Then you get 10 equals to minus 5t square plus 20t plus 15. Or you can bring 10 here, get plus 5 here, factor out 5. It's a simpler equation to work with. Do you understand? And get your answer. Now the last question is state domain and range of the ball's flight. Now as you can see from here, that the graph will be actually kind of going like this, right? It is like this. So here, what we have here actually is, this is the height from which the ball is thrown. This is when you reach the maximum, and that is when it reaches the ground, right? When h of t is 0, this point. Now, domain is from 0 to this point when the ball reaches. So that gives you the domain from 0 to this t. And the range is less than equal to the maximum, right? So point how high the ball reaches, which is this. So you can relate all these and write on your answers. I hope these hints and steps help you find the solution of this question. Right? I'm not really giving you all the answers since this problem is very common and you do have examples in your book. So go through those examples. That is my recommendation. Thank you and all the best.